achieve ad hoc message authentication over social media platforms. So the domain, as stated here, is social media platforms. The problem we're addressing is validating the integrity of content shared between SMP users within social media platforms. And typically the research is characterized as a multi-channel overlay authentication protocol. All right, so I assume everybody knows what a social media platform is, fairly standard stuff. What's quite interesting with them at the moment is that they're generally starting to be used beyond their traditional remits. So whereas they would once have been typically for social network purposes, they're now being used increasingly for file sharing and so forth, and as such they start to incur additional issues pertaining to the transmission of data over public networks. So typically where we would expect authenticated users to log into a social network, and traditionally where users assume that those social networks are actually secure, they actually do carry a number of problems that are very, very akin to transmitting data over public networks. So the scale of social media use is massive. Of a population globally of approximately 7 billion people, some 2 billion people apparently have active accounts on social media. That's approximately 29% of the global population, and of that, 1.65 billion are using them via mobile. So you can start to see that with the traditional infrastructure of using landlines and regular infrastructure, if you start adding mobile infrastructure and data transmitted over those structures, you can start to see where problems may arise in terms of potential security problems. So within the social media domain, there are many, many areas that would constitute a research problem. However, we tend to focus in this particular research on integrity threats to user content. So those threats typically are occurring from content reformatting, image cropping, resizing, and watermarking, and metadata changes. And these are typically things that are being applied by the social media platform themselves, not from outside users. This is coming from the social media platform. And as such, if I as a user want to communicate information to somebody else, my concern now is looking at the social media platform as being adversarial rather than worrying about external forces being adversarial. Right, okay, so just a couple of definitions. I mean, we classify this as message authentication. So if I go to this slide here, so Alice effectively wants to transmit a message to Bob, and where we refer to a message M as being anything from audio, text, image, video types of content, the concept basically being is how can Bob authenticate that M has been transmitted with valid integrity. So how can Alice confirm, or how can Bob confirm that any message he receives from Alice has not been modified by the social media platform en route? That's the general goal we're looking at. Right, so our work was originally inspired from work that derives from wireless device pairing of ad hoc devices in wireless networks. So in essence, we've got two channels, typically, an out-of-band human authenticated channel and then a wireless channel that's deemed to be insecure. And within this context, I'll go through the little workflow. The claimant applies a hash function to a message derived in a digest. That digest is concatenated with a secret key. The hash function is reapplied. And then the claimant sends the key let's go back one, I've gone slightly too quick. Let's go back there. Right, so claimant sends the key, followed by the digest, and the message itself, and then at the other end, the recipient or the verifier has to then authenticate this information. So effectively what they do is they repeat the process. They apply a hash function to M to derive D, concatenate that with the secret key they've received, and then in essence, if these two values actually match, then the verifier can effectively authenticate the entity of this claimant. They can verify that this entity was in possession of these elements in order for them to calculate those values. So we take that basic concept and we basically strip it right down and we apply it to content shared between users. All right. So our approach is generically the same. However, we do have some differences. So we authenticate content and not entities. That's the first thing. So typically we express things in terms of a sender and a receiver, or Alice and Bob, as is conventionally used. The other thing is we don't have a secret key. We're not sending anything that we want protected. It doesn't matter. We're interested in making sure that content has not been changed by the social media platform. Okay. So we do take some. We have some assumptions. So first thing is that we assume that SMP channels are independent and non-colluding. So, for example, WhatsApp are owned by Facebook. Instagram are owned by Facebook. Sorry about that. Right, so WhatsApp are owned by Facebook and Instagram are owned by Facebook. So we wouldn't combine those two, we wouldn't pair those as channels. So typically you might use, say, Viber and Facebook because they are independent. They don't have any commercial benefit in trying to exchange data with each other or exploiting each other's data. They are considered to be independent. The other thing is we assume that links between users and SMPs are actually HTTPS secured. And typically that SMPs establish authentication such that if Bob receives a message from a claimant claiming to be Alice, that the SMP can be trusted to deliver that message that comes from Alice. We know that the entities are secure. We also assume that SMPs actually eavesdrop on content and that they may modify it. We know they do. It's something we have to accept. And so any solutions that we propose has to work within that kind of remit. So our approach is really, really simple. All right, so we apply a hash function to M, derive a digest. The digest is transmitted to Bob from Alice. Alice also transmits M. Bob applies the hash function to M, and the same thing applies. If they are the same values at the other end, bearing in mind these are cryptographic one-way hash functions, so we can't fake the results of these, then we can say that the message that was transmitted between Alice and Bob are authentic. All right. However, one thing we can't mitigate for is if they don't match, we can't say which channel was modified. All right, so just as a quick summary, the approach is, in terms of its benefits, the approach is very simple and intuitive to implement. It's scalable. It can be used as a probe to identify SMPs that do modify. So for example, if Alice and Bob wanted to exchange, say, steganographic information, and you wanted to find out whether the channel was secure for that purpose, you could use it as a probe for that purpose. So you could send something to you could test authentication, and theoretically you could then verify that a channel could be used for the purposes of transmitting information that should not be modified. One limitation is that messages that are transferred, or the authentication signature that's transferred, is a digest. And so those digests have to be published within social media platforms in a way that is contextually relevant. So for example, if Alice sends a message to Bob that says, "Hi, how are you?" and then it's got a digest tacked on the end, that isn't what we'd class as contextually relevant. It stands out. It would look innocuous. It wouldn't be innocuous. So there would have to be a way of actually ensuring that the messages that are transmitted are sent in a manner that is innocuous. One way we can do that is to use steganographic techniques. In terms of some prerequisites, participants must have pre-agreed accounts on SMPs, social media platforms. They must have a cryptographic hash function tool, and they must have an agreed steganography tool if that is an issue that they want to get over. I guess the other question is where this might be relevant, where is it applied? And I guess one of the key things is in the context of a scenario where content is shared that needs to be validated as being unchanged. So, for example, increasingly, the number of the number of testimony coming from the public pertaining to images they've taken, videos they've taken, that they've taken on mobiles. If we look at the pervasiveness of mobile phone devices, and the fact that increasingly on journalistic sites that content is now being included as content. So, for example, when you and I witness to a particular event, and you're starting to see lots of information and lots of content coming from members of the general public. At some point, if that is ever required to be validated as being genuine, we'd have to be able to confirm some way that at any time during its transmission, so for example within a forensic structure or a legal structure, that it has not been modified. And it's in that sort of context that I'd see this being applied. And that's it. Thank you very much.